We're all here to learn. So the things you should have gotten from the videos: what is the rate of change? What is the name for the rate of change of a line? And how do you find the slope of a line if you're given a graph, 2 points, or an equation? And what is a slope-intercept form of a line? And can you interpret the meaning of slope and y-intercept in an application or word problem? And what is the slope of a horizontal line and of a vertical line? And can you determine whether equations of lines represent parallel or perpendicular lines? So those are what the video is all about. Then, what's happening here? Why did this not go to the slide? You know what? I think did it go to the next slide for you guys? No.
Not for me.
No, it stayed on that same slide. Dadgummit. Okay.
Yeah.
Here. So today we're going to be using this paired deck application, and hopefully I can, sometimes I wonder about these things seem to work when I'm at home alone, but then I go to do them with students and it's always an adventure. So to go over the book problems from sections Maricheck 3.2, and these are the problems that we're going to be going over. And these can also be found under the homework worksheets in Blackboard. And as always, need to be turned in with the written exercises also found under that same tab. And remember, the book work that we complete in class counts as 50% of the grade, and the work that you do on your own on those written worksheets is the other 50%. So here we go. We're doing the first problem on today's homework, and I would hope that someone can help me do this. So I want all of y'all to find the slope of this line, and then we'll talk about this. So if everyone will do that, and
sometimes it's kind of hard to
what? Yeah, you know what I noticed when I was doing these is that they're real picky. I mean, it's like you look at this one and it looks like it's, to me, when I first looked at it, I thought, oh, the slope is 2. But be really careful, and we're not going to be this picky on a test or anything. I mean, we'll make sure it's not so, what's the word?
Make sure it's more legible than this, I think, a little bit. It's hard to read it on this one.
Well, it is hard, and the rest, and all of them were kind of hard to read. So, I mean, I wasn't impressed at all with the, so just make sure that you know.
And I think I've said it a few times, but like, make sure you get a point where like the line is actually going through it, right? Don't try to like, kind of guess like a half point or something silly like that.
Right. So kind of on this one, and again, I think it's kind of picky, but like if you picked this point right here, I always, if I can, I always like to pick a point on the intercept. And then like this one right here, it's not really on it. So the first one that I see that's really looks like it's really on it is right there. So that would be, just be careful, because like I said, sometimes these are not that clear. So let's see what y'all are saying here.
So like, would we be graded more for how we did it, not necessarily what the numbers are?
Well, we'll make sure that they're not ambiguous is what I'm saying.
Okay.
Okay, they won't be like these. They'll be very clear. We might even, I mean, I might even mark 2 of the points just to make sure that y'all know responses. And there's only there's only 7 people logged on, so I'm hoping more people will log on, because I'm only seeing, and most of y'all are getting this right, but just join. And it is, the password is GYOSH. Okay, so I can't really see who's here. So would someone like to volunteer and tell me what they got?
2/5.
And that's Chris?
Yeah.
Okay, yeah, 2/5. Good, thanks, Chris. Check you off. So it is 2/5. If you look at this, remember we're counting rise over run. So we would rise 2 and run 5, or we could go down 2 and run to the left 5. So either way would be fine.
So like right away, I hope you can tell me like whether the slope is like positive or negative, right?
Absolutely. Right.
Left to right's positive, right to left is negative, right?
Well, if it's, what are you looking for as far as left to right?
So like how the arrow's pointing. So if the arrow's like pointing down left, but it's pointing up right, that's positive. But it's like pointing up left, pointing down right, that's negative.
Yeah. Good. So who can tell me what the slope here is?
I got 5/4.
Nice. It would be 5/4. Let's look at that. And that was Michael, right?
Yeah, but it's just this one looked a little bit more clear where the points were than the last one.
Yeah, it does a little bit more. So here, like again, I try to find the one on the intercept if I can. And then the next one looks like it is right here. Is that right? Up 1, 2, 3, 4. Nope, right here. See, I think they're ambiguous. I really do. But you can kind of, so up 5/4, that would be. But like I said, we will either make sure that you know which points you're going from so that it won't be that ambiguous. Sure, hopefully.
If they're looking at it on a computer, I think they could probably zoom in on it a little bit better. Probably. Like
Yeah.
do Control plus and try to zoom in and see. But I mean, that also depends upon the resolution that the book is in. So I don't really.
Yeah, the book is not that great of a resolution. It's just not, but that's okay. I mean, so it should be 5/4. And again, guys, if you need help, just holler out, say, I don't agree with you, or where the heck are you getting that? And we'll stop and talk about it. Okay, again, so like Matt said, the first thing you should do is determine, is this slope going to be positive or is it going to be negative? And then go from there. And again, for those of you that may have just come in, Matt, are you watching to make sure people are being admitted?
I can't watch that because I'm not host.
Dadgummit. Okay, I need to make you host. Let me make sure people are here. I'm gonna make you host again, and I'll figure out how to. Well, if I make you host, they can't see my screen though, right?
I think it'll still show your screen.
Okay. That way you can watch out for people. Okay, so someone want to tell me what the slope of this line is?
About -1/3.
Is that Aurora?
Yes.
And you said -1/3?
Yes.
Perfect, yes. -1/3. Oh, here we would say, let's see how many people got that. Yeah, every single person that's on here got that. Great, that's great. So -1/3 here, again, pick up the y-intercept if you can, and then we would go down 1 and to the right 3. And it's rise over run. So it would be -1/3. Excellent. Last one where we're asked to find the slope again. Determine whether it's positive or negative first. Whoops. And then good. People are getting it. I'm liking it. Everyone that's answered's gotten it so far. That's awesome.
Yeah, I think I might have picked the wrong points again on the line. What are the points on this one, the coordinates?
Okay, I'll show you. Hold on. Good question. I know they're kind of ambiguous at times. Let's see. So they would be right here. And those would be 2 good points. And again,
Yeah,
we'll,
see, I'm off. Yeah.
yeah, it's super easy to get off on these. I know that's, I did the same thing when I was doing it. What kept me going is like, if I can go do another, like 1, 2, 3, 4, 5. If I can keep going and it still stays on the line, then I know I'm doing it right. You know what I'm saying?
Mm-hmm.
I have a question.
What's your question?
How do you get the 5? Is it because like you count 5 up and then you go down?
So how do I get on the what?
How do you get 5?
The 5? Okay,
Yeah.
so like I said, these are kind of ambiguous because like when you first look at this, you might go, for example, think it's -2, right? So you might go, okay, I can go down 2 and over 1, right? So you think the slope is -2, but then if you go down 2 and over 1 again, you're off the line. You see that? So that's how you know that's not the right one. But we aren't trying to trick you like that. I mean, I just, so if if we were actually doing this, we would make sure that there was no ambiguity, or we would actually put 2 of the points on here for you so that you would know, okay, these are 2 definite points on the line. And to count from this one to this one, I would count down 5 and over 2. Does that make sense what I just said?
Yeah.
Okay.
Thank you.
Yeah. So it is -5/2 on that one. Okay. So this one says find the slope of y equals 3. What kind of line is y equals 3? It's getting it so far. That's very good.
Yeah, and in the next section, we start defining slope intercept. And so this comes up into play in the next section as well.
Well, yeah, but it's this section as well. It's 3 point, I mean, yeah, it's the next few problems is slope intercept. But everyone is getting this right, so that's awesome. Okay. So, let's look at this. Y'all are doing really good. Okay. Okay, so y equals 0. If we looked at this in slope-intercept form, it would be y equals 0x plus 3. So the slope is 0. And 0 slope is always going to be a horizontal line. If you look at the letter Z, it kind of has a horizontal tendency, as opposed to no slope or undefined slope. No is kind of an up and down word. So no slope, if you're finding the slope, it's when you have a 0 in the denominator. And 0 slope is when you have a 0 in the numerator. In this case, it's just the equation y equals 3, and that would be a horizontal line with 0 slope. And if you have x equals to a constant, that's going to be a vertical line, and it will have no slope. So use the slope formula to find the slope between these points. Number 85 on the homework. So hopefully you're all working along with me. So you'll have your homework completed by the end of the most of y'all are getting this right, but
What is it?
some are getting it wrong. So be careful.
Is the answer -5/2?
Well, we'll talk about that in a minute. But I want to make. I'm looking at what y'all are answering, and I'm seeing some correct and some not correct. So I want y'all to answer it and see.
Oh no, you gotta make them a positive. I forgot.
So who was that was just asking me a question?
It was me.
Is that Chris?
Yeah.
So what do you think it is?
So from the lecture notes, I remember that you can't really have a negative, so you gotta make it to a positive. Originally I got -5/2, but I wasn't sure if I should switch to +5/2.
Why would you switch to +5/2? What were you thinking?
The lecture notes, like it would be like easier to read or something like that.
Okay. So I think your initial response was right. Be really careful. Slope is y2 minus y1 over x2 minus x1. And so like this one, I would call this x number 1.
So -5/2.
X number 2, yes.
All right, so I was right then.
Yes, you were. Y number 1 and y number 2. And it doesn't matter which point you call x1 and y1 and which one. Just make sure you're consistent. So you would take y number 2, which is 0, minus y number 1, which is 5, and that would give us -5. And then x number 2, which is 4, minus x number 1, which is 2, and that would give us 2. So the solution should be -5/2. So just really watch your signs and really be consistent with the points as far as make sure you don't mix up the x's and the y's as far as the order. Because you could also say this. You could also say 5 minus 0 over 2 minus 4, which would give us 5 over -2. And that's the exact same thing. I always like, in the end, if you wrote it like this, that would be fine. But ultimately, I always put the negative in the numerator. That's just for consistency's sake. because so you know that it means the same thing.
Yeah, I was gonna say the most common thing I see here is like people will swap that order that their Y2 and Y1 are in. Like
Right.
it doesn't matter which pair or which ordered pair you label with the 1 or 2, but you have to keep them consistent. And if you swap the order, it's going to end up giving you the positive 5/2, right?
Right.
Yeah.
Again, guys, if you see something you don't like or you don't understand or you just want to talk about something else, feel free. That's what we're doing this for. Okay, so again, find the slope here. Y'all be careful because this is where, like, if you on the test, if you were missing adding and subtracting using negatives, then this is where you have to be super careful. Most of you are getting this right, and that makes me happy. So just know that, like, I don't know, one of my greatest pleasures is to pick distractors that are really good, because I know they'll fool you. We don't do multiple choice tests in this class, but if we did, you would be super sorry, because if whatever wrong answer you could think of, I can think of it too. So don't be discouraged if you're getting wrong answers here sometimes, because I do tend to pick some good wrong answers. So here, whether you do 3 minus -5, and -5, those double negatives make it a positive, so that would be 3 plus 5 is 8, over -3 minus 4. Remember, if the signs are the same, you add the numbers and keep the sign, so that's -8/7. And if you reverse the order and do -5 minus 3, you would get -8, and 4 minus -3 would give you 7. So either way you do it is fine. Just make sure that you're consistent with whatever point you decide to be your first point, and whatever point you decide to be your second point. Good. Most of y'all are answering right. I do have a couple people that are not, so watch it. So we have, I labeled this x1 and negative 5y1 and 1 x2 and negative 2 y2. So I took y2, which negative 2 minus y1. So that would be a negative minus a negative 5. Remember, a double negative turns into a positive, so that would be negative 2 plus 5, which is 3. And then 1 minus 4, since the signs are opposite, you would subtract those two numbers and you would get 3 and take the sign of the larger number. So it's 3 divided by negative 3. So the slope would be negative 1. That's really a big deal. So if you are answering 1, make sure that you go back and see why it should be negative 1. Does anyone have any questions about that? Also, guys, if you're unsure, you can always plot the points and see what they are. So like here, 4, negative 5, and 1, negative 2, and you see that the line is going down from left to right, so it would have to be negative. So if you're ever not sure, plot the points and look at them. You really do need graph paper. You can either Google it and pull it up, or you can buy some graph paper at the grocery store, but it really is good to have graph paper. If you freehand it, it's not like we're going to count it wrong, but it's much clearer, and sometimes you need the exactness of graph paper, so it's always good to have it. We have one person that's responded to this one, so. The 4 people that have responded have all gotten it right. Oh. Paige, did you do this one? People's mics aren't working. Leslie, did you do this one?
Yes, I did.
Oh, great. Can you tell me how to do it?
So I pointed like the -1 to -4, and then I just did, I went up 4 and then over 3. So that put me to 2, or 2/1, or no, 2/0.
So you started at the point -1, -4, which would be right here, and then you went up 4 and over 3,
Yes.
which was right there. And so the x-intercept would be 2, 0, right? So if it's on the x-axis, the x-coordinate comes first and followed by a 0. If it's on the y-axis, you have 0, comma, whatever the y-coordinate is. So that would be it right there. Thank you. I did have a couple people put 0, 2, and that would be on the y-axis. So make sure you don't reverse. And that's another reason that we like you when we ask you what's the x-intercept, what's the y-intercept. We want you to put the ordered pair. We don't want you just to put the number, because the ordered pair shows you know where it is and how to label it. Everyone that's answered has gotten this right. Awesome. Good job, guys.
Wouldn't the y-intercept be the 1?
What's that?
Wouldn't the y-intercept be -1?
So yes, it is. Chris, you want to tell me how to do that? How to do it?
It's kind of easy. I already gives it to you like on the question.
It does. That's right.
Yeah, so basically the slope is the x and right next to it. Literally, that's the answer, -1. So.
-1, right? That's the y-intercept, exactly. 0, -1.
Or y equals mx plus. Well, or technically it would be your b, since that's how it's y
That's
equals mx
B.
plus b.
That's right. B is your y-intercept. That's exactly right. And then from there, what would you do?
I would just graph it. So put a dot on the -1
Uh-huh.
on the y-axis, and then I just
Yeah.
go up 3, and then 1
Mhm.
because
Yep.
rise over run,
Right.
and
So
then just do the opposite on the bottom. Sorry if I cut you off. My bad.
right. Good job. So this tells you where to start on the y-axis. That's your B. And then this tells you where to go from there. And 3 is the same thing as 3/1. So you would go up 3 and over 1. And I usually like to do it several times. Just I get satisfaction out of doing it. That way I get a nice line. And the reason I put this is because a lot of times people tend to put the X in there when I ask for slope. The slope is only the number that's right in front of the X, and only if the equation is solved for Y. So for example, if we had something like this, y minus 2x equals 7, and I asked you for the slope, you would not tell me it was -2 because this is not solved for Y. It has to be solved for Y before you can look at it and tell what the slope is. So you would have to add 2x to both sides first. And then you could tell me what the slope is.
It's been a few days since I recorded that video, but if you throw in the x, that's throwing in a variable. And the thing about slope is really, really supposed to be a constant rate of change. So I don't know if I emphasize like the word constant, but it's got to be a single number. It's got to be constant, right? Anywhere
Right.
you draw that little triangle, it's going to be the same shape of that triangle, right? It might be larger scaled, but it's going to be the same shape triangle. If we get curvy lines, we don't get the same shape triangle, right?
Right. Yeah, that's really, I don't have that many pet peeves, but that's one of them is when people put the X on with the slope. So don't do it. It's not right. Olivia, did you do this one?
Yeah, I did.
Can you tell me what to do?
Um, I got for the slope, I got -2/5.
Mm-hmm.
And
I did,
for,
and that's okay. Sorry, Olivia, I just wanted to make a point. I did have a couple people tell me -2/5x.
Sorry about that. The power went off. I had to use my phone now. It's still raining here in San Marcos.
Okay, go ahead, Olivia.
and then for the y-intercept, I got -3.
Yes. So there is our y-intercept is 0, -3. And from here, we're going to go down to and to the right 5. Or we could go up to and to the left 5. But we know that the line has to be pointing going downward. Any problems with that? Remember that if the equation is solved for y like it is in this case, that this is your slope right here, and this is your y-intercept. So here the book asks just what is the most convenient method to graph the line, and it didn't really ask you to graph it, but I would think that you would graph it. So I want you to graph it and tell me what the most convenient method is. And honestly, I don't care if you pick the most convenient method. I just want you to be able to graph it. So however you the thing is, if you know the easiest method to graph this, then this is like a snap. It's like it takes you no time at all. If you have to think it through a little bit, that's okay too. It just takes it a little bit longer. But everyone that's answering is getting it right. So
So if you're trying to find the graph, the line on X, basically if you're trying to graph something that's on the X axis, you like graph it vertically, but if it's in the Y axis, you graph it horizontally.
if it's x equals to a constant, is that what you're saying? You would graph it?
Yeah, like to like a single number. It's not like a variable or whatever.
Right. Right. And we'll talk about, let's look at that. Okay, good. Y'all are doing good. And someone said use a table and plot points, and honestly, that would be fine, just as long as you get the answer right, you know. So let's look at this. Okay, so one method would be, okay, x equals 2. So if we do a chart, which is not this is not the most convenient method, but it is definitely a method. X, no matter what, is going to be 2. So x can't change. Y can be any number we want. If we plot those points, we would get 2, 2, 2, 0, two. Get those, and if we connect them, whoops. Y'all get the picture. Connect them, you get a vertical line through. So if you recognize that x equals to a constant, that means just to a number, is going to be a vertical line. Then you're in good shape. But if you don't, then just plot some points and you'll get it too. Again, there is a most convenient, easiest method to graph this line, but just as long as you get the correct line, I don't really care what method you use. Okay, so I have an even number of people use the slope-intercept method and plot by using the intercept method. So okay, so I would definitely think that the easiest way to do this would be the slope-intercept method, but we'll talk about all the different methods. So here, the slope would be -3/1, and the y-intercept would be 0, 4. There's one method of graphing. Then some of y'all said plot the x and the y-intercepts. If you did that, so the x-intercept, well, we know the y-intercept is 0, 4. And the x-intercept is going to be something 0. So if I plug 0 in for y, I would get 0 equals -3x plus 4. And then I'd have to solve that for x. So I'd say -3x equals -4. So x would equal to -4 divided by -3, which is 4/3. So the x-intercept would be 4/3, 0. Let's see if that falls on this line. So 4/3, 0 would be a little bit more than 1. And that would be like right there. And that would work. Okay. The other way would be to use a chart, plot some points. Like I'd pick like -2, 0, and 3. I always like to pick 3 points. It only takes 2 to graph a line, but I like to pick 3 as my checkpoint. So -3 times -2 is 6 plus 4 is 10. 0 times -3 is 0 plus 4 is 4. -3 times 3 is -9 plus 4 is -5. So let's see if those points would fall on this line. So -2, 10, be up here. 0, 4, we already said that one was on there. And 3, -5. So any one of those three methods would work. The most convenient, the easiest would be knowing that that is a slope-intercept form of a line. I'm getting all kinds of stuff here, and that's good. But I'm going to ask someone to explain each part, because I see people picking all three of these, and that's fine. Okay, so several people said they would use a table and plot points. So would someone who said that tell me how to do that, please?
You mean like a T-chart, right?
Yeah. Did you say
Yeah.
that, Michael?
Yeah, I just thought that table meant T-chart.
Okay, that is what it means. So can you tell me what you did?
Well, I mean, I didn't actually do it, but I mean, so,
Okay.
because it's all jumbled up. If you just plug in numbers, then it's a lot easier. Because it's
Okay.
not in the slope-intercept formula.
Okay, so but you're saying plug in numbers?
Yes, like you plug in 0 for x, for example, and then you just solve the equation.
Okay, so you didn't do it that way though?
I don't have a lot of room on this paper. I just put, because the questions here are actually a little bit different. I put 121. I found the slope,
Okay.
and then I drew a little graph, but I didn't write it in a sentence like these answers here, so I don't remember. But I just know that a T-chart is easier when it's jumbled up like that.
You think it is? Okay. So did someone do the T-chart that can tell me what they put?
I always start with 0 because it's very close to the
All right. So if you put 0, what would your Y value be?
let's see here. I guess Y would be -1.
Uh-huh.
Yeah.
Okay. And then you have to have at least one more point, so pick another number.
I'll make Y 0.
Well, you want to pick, well, okay, so you're going to make Y 0. Okay, so what
Yeah.
you're really doing is called the intercept method, but that's fine. Okay,
Oh.
so if Y is 0, what would X be?
1.
1, right. And that's a perfectly fine method. So 0, -1 would be right here. 1, 0 would be right here. And then you just connect the points. So that would be the intercept method, because we found the X-intercept and the Y-intercept. That's a great way to do it. The slope-intercept method, would someone tell me what they would if they use the slope-intercept method? Anyone that used that method? Okay, so well, the slope-intercept method, you would solve it for Y. So you'd say x minus y equals 1, negative y equals negative x plus 1. So y would equal to x minus 1. So the y-intercept would be negative 1. And the slope, if there is nothing in front of the x, that's automatically assumed to be a 1. It's implied 1. So here we would start at 0, negative 1. And then we would go up 1 over 1, and we would have exactly the same graph. So that's the slope-intercept method. And plotting points basically is exactly the same thing as this, except for you might pick a few more points. So any of those methods is fine. The most convenient method, if you asked me, on this one would be the intercept method, but you could disagree with me on that. Now this one I definitely have strong opinions about, but again, you might disagree with me.
So in order to get full credit, do you want us to graph these last 4 problems?
The ones we just did?
Yes.
I would really like it. I'm not going to count off if you didn't, because the book didn't ask you to, but I really think it's helpful to graph them and think about why you chose the way that you chose to graph them. Almost equally between 2, and I have no problem with that. Here's the third one, that's fine too. As long as, Timothy, which method did you choose?
I use the slope intercept method.
Slope intercept? Okay, so tell me how you did that.
All right. So for 123, 3x minus 2y equals negative 12. For that, I added 3x to the other side, and it became negative 2y equals negative 12 plus 3x. Sorry about that.
Did you mean subtracting 3x from both sides?
Yes, my bad.
Okay.
I'm sorry. Forgot the other.
No, that's okay.
All right. Now you're going to divide negative 2 on the other. And you should come out to y equals 3 over 2 minus 6. I'm sorry, plus 6.
Right, because you've got double negative.
Right, and your y-intercept should be 0 dash 6.
Right. Okay, so did anyone that did the intercept method, could they tell me what they did? Okay, well, I like exactly, Timothy did great, but another method that I really like is the intercept method, where you just plug 0 in for x and find what y is. So if you plug 0 in for x, that's like erasing the y, because that's, I'm sorry, erasing the x, erasing the y. And you would get negative 2y equals negative 12 if you erase the x part, because you plug in 0, that just makes the x turn into a 0. And that would give you, y would be 6. And then if you want the y-intercept, you plug 0 in for y, and you're looking for the x value. No, I don't want to open this apart. So that means that you would erase the y part, and you get 3x equals negative 12. Dividing both sides by 3 would give you x equals negative 4. And then you would just plot 0, 6 and negative 4, 0. Whoops. My graph was a little bit off, but that would also give you the equation, the line that you want. And of course, you can also just plot points, and that's always, you can always do that if you want to do that. It always will work for you. Okay, so here we are at the application problems. Bruce drives his car for his job. The equation R equals to 0.575 M plus 42 models the relation between the amount in dollars R that he is reimbursed and the number of miles M he drives in one day. Find the amount Bruce is reimbursed, this is part A of this problem, on a day when he doesn't drive any miles. He drives 0 miles. How much does he get reimbursed?
So there's an idea I kind of saw online that someone posted that might kind of help some people. If you need like some kind of way to like do a low budget like dot cam, you can use a CD or a mirror. And I think maybe if it'll work, I don't know. It might be. Is that the right direction or is it mirrored? It looks like it's the right direction, right? Yeah, it might be mirrored. So you might have to go in and mirror your Zoom account, which you can do with the options. You can mirror your image. But yeah, my camera is a really horrible camera. It's what they call a nose cam, so it's like really down low. But if your camera's up high, I saw people they taped a pencil to the back of their laptop, and then they would tape a quarter to the CD to give it a little weight, and it'll actually like you can just hang it there basically, and you can remove it and put it back. But yeah, you can do it with the CD. The other thing I was thinking is like a compact mirror might also help. So if y'all want to show us like what work you're doing, get a little mirror or something that might help.
That's a great. People are so innovative.
Necessity is the mother of
Isn't it? It's so true. Okay, so let's go on this one. Let's see here. Most of y'all are getting this. Okay, what you have to remember on this is actually just the same thing as R is like your Y and M is like your X. And the y-intercept is going to be like 42, and your slope is going to be 0.575. So the amount Bruce is reimbursed on a day when he drives 0 miles would be R equals 0.575 times 0 plus 42, which would be $42. Okay, so, and again, I really would like to say, you just say Bruce is reimbursed $42 on a day when he drives 0 miles. And at the very least, you want to make sure that you put the dollar sign in there, because otherwise it's like 42 what? I don't know. All right, then it says find the amount Bruce is reimbursed on a day when he drives 220 miles.
When we had to put 220 miles to the M, so multiply was 0.575.
That's right.
Yeah. Oh. This is like plugging into M and multiplying it, basically.
That's right. This hour goes by, I mean, this time goes by so fast to me. It's like, anyway, we're running on the end of here.
This section had a lot of problems in it. They were kind of quick. A lot of them, I think.
Yeah.
But there are a lot of them.
Yeah. Okay, so. Okay, so here, if you want to know how much he's reimbursed when he drives 220 miles, you just plug in 220 for the M, multiply it by the 0.575 and add it to the 42, and he would be reimbursed $168.50. Interpret the slope. Okay, and when we say interpret, it's in your own words. So there's just the way that I say it may not be the way you say it exactly, but that's okay. Just make sure you understand what the slope is doing in this problem. Okay, so in this problem, M is the number of miles. So for every mile that Bruce drives, he will be reimbursed an additional 0.575 cents. So to figure out how much he's going to make, you just take the number of miles that he drives and stick that in for M, because for every mile he drives, he gets another 0.575. So if you're picking these solutions, it would be the first one, A. Most of y'all got that right. What does the R-intercept? And remember, the R-intercept is really just like the Y-intercept. So what is that and what does it mean?
The reimbursed miles.
What does it mean exactly in the problem? What is its special meaning?
I want to say slope, but I'm not sure.
Well, what is the slope in this problem?
Oh, never mind. It's 0.575. My bad.
Yeah, right. Okay. No. I want to make sure we get to the next one. So I'm going to go ahead and talk about this one. So on this one, the 42 is the R-intercept. And that just means that no matter what, he's going to get that $42, even if he doesn't drive any miles. And from there, it just goes up by the 0.575 cents per mile. So he gets $42 just if he doesn't do anything, which doesn't make much sense to me, but that's the problem. So in this case, the R-intercept is 42 and means when the number of miles driven is 0, Bruce still gets $42. So that's the starting point. And from there, he makes more money. Okay, so when graphing these things, this is where I want you to think about this. What would get some good things to consider before you just start graphing? First of all, if it's an application problem like this, usually you're only going to be concerned with the first quadrant, right? Because you're only going to be talking about, you're not going to be talking about negative miles or negative dollars. Usually you're just going to be working with the first quadrant. So let's see here.
I'm going to drive the whole thing in reverse.
So usually what I do is I just start out with, make sure that you get the first quadrant. So that's a good thing to consider. With an application problem, usually you're just working with the first quadrant. Secondly, what we're looking for, super important, is to label your axis. Okay, so the vertical axis is going to be what? And the horizontal axis is going to be what in this problem? Can someone tell me?
X and Y.
Okay, they're X and Y, but what does X stand for in this problem? We've got two things. We've got money and we've got miles. So which one would the X axis stand for?
The M and R.
575.
What?
X is for 0.0575.
Okay, that's the slope of the line, but the graph we're trying to talk about is, what we're trying to do is find out how much he is going to be reimbursed, right? So this axis, the x-axis, is going to be what? What determines how much he's going to be reimbursed?
It's going to determine his reimbursement.
Miles.
Miles, right. So so make sure you label your axis. This is going to be the number of miles. And then what would the vertical axis be? What would that stand for?
Reimbursement dollars.
Yeah, right. So the amount that he's reimbursed, right? So this is going to be the amount reimbursed. I don't know why I did that double. So it's important that you label your axis. All right, now we need to decide on our units. You know, where do we do our units? Okay, so a lot of times I like to plot a couple of points, and that helps me to kind of figure out how to scale my my graph. So like, for example, I know that if he drives 0 miles, then he's going to get $42, right? And so probably he's going to be driving more than, you know, if he's driving for a living, I would pick another number like 20 or even more, and figure out what that is. So if you take, let's say 200 for fun. And your scale might be different than mine. So if I say 0.575 times 200 plus 42, that would give me $157 that he's getting. Okay, so what would be a good scale for this, do you think? I mean, and again, yours can be different than mine, but I am going to make each one, and your graph paper might look different than mine. So I'm going to make each one of these on the R. I'm going to let these be 50s. You don't have to do that. I'm just saying that that might be a good number to do. And then on the, I'm going to go ahead and let these be 50s on here too. You can make the X and the Y axes have different, a different scale. So when I start here at 0.42, 42 would be like somewhere right under 50, right? And then another point would be 200, 157. So 200, 157 would be like right here. Just, and then you can just draw your line using those 2 points. So that'll give you kind of a good idea of what's happening. So the things you really need to consider are that you're working in the first quadrant. You need to label your axes and figure out what your units are going to be, your scale. And I know it's time to go. I'll definitely post this in the solutions. But if you want to hang with us, we'll go ahead and finish this out. Okay, so this one says, Cheryl works in retail and her weekly sales include commission for the amount she sells. The equation S equals 400 plus 0.015 C models the relation between her weekly salary in dollars and the amount of her sales, C, in dollars. So it says find Sherry's, or Cheryl, or what, oh, it's Sherry. Sherry's salary for a week when her sales were $0. How much did she make if she didn't sell anything? So that would be $400. So when her sales are 0, she would still make $400. And then it says find Sherry's salary for a week when her sales were $3,600. Would make $940. Then it says interpret the slope and the S-intercept. So the slope is the number that's in front of the C. So the slope is 0.15. And that means for every dollar she sells, she makes an additional 15 cents. And again, you can interpret, you can write it however you want, just as long as it makes sense and it's right. And then the S-intercept is like the Y-intercept. And that would be 400. That means if she makes $0 in sales, she earns $400. So now we're going to graph this thing. And again, we're only talking about first quadrant because we're not, she's not going to make negative sales, not going to make negative dollars. The minimum that she can make is $400. So the x-axis or the c-axis is going to be what?
Commission or dollars?
Yeah, number of sales for every, yeah, for the dollars in sales, right? Good. And the y-axis or the s-axis is going to be what? It's going to be the amount she makes, right? It's going to be her salary. Okay. So again, I'm going to go ahead and plot a couple of points so I know if she sells 0, she didn't sell anything, she makes $400. And I don't know, she works retail, so I don't know. Again, let's say she sells $200 worth of merchandise. Then she would make 400 plus 0.15 times 200. And that would be $430. Okay, so again, you can decide what you want to do as far as the scale goes. I'm just gonna let it be 50s again, but it doesn't have to be. But you do need to label. You don't want to leave it blank. You need to label the scale so we can see it. So 0 to 100 would be right there. And then 200, 430. Would be like somewhere right there. Oops. Okay, the last thing that we're doing is using slopes and y-intercepts to determine if the equations are parallel, perpendicular, or neither. So before I get into this, I just want to remind you, if we have the regular line, our original slope, the slope of the perpendicular is always going to be opposite and flipped or reciprocal. And the slope of the parallel is going to be the same, exactly the same.
I just wanted to comment here. I'm actually glad that you guys give us the option of staying here or leaving to continue to work on the problems. I actually want to do that.
Okay,
That
good.
doesn't bother me at all because I
All
can,
right.
if I have to go or if I have to stay and, you know,
Yeah, that's
really
what I
helps.
figured. If you need to go, you can go, but I'm hoping, anyone that wants to stay is welcome to stay.
Yeah, I
So
mean, sometimes math, you need more than just an hour.
yeah, true that, especially if you okay, so let's say our original slope was 2/3, then the perpendicular slope would be -3/2, and the parallel would still be 2/3. Let's say the slope of the original line was 5, and that would be the same thing as 5/1, so the perpendicular would be -1/5. Parallel would still be just 5. Let's say that the slope is -7/8, then the perpendicular would be +8/7. You always take the opposite sign and flip it for the perpendicular. For the parallel, it's exactly the same number. Let's say that the slope of the original was 0. Then the perpendicular would have no slope, which is the same thing as undefined slope. And the parallel would have 0 slope. And if the original is undefined or no slope, then the perpendicular would be 0 slope, and the parallel would also be undefined or no slope. So here on this first, I want number 133, the slope of this second line is easy to see. It is 3/4. And the y-intercept is -3. But before we can see that, here we have to solve this one for y. So we subtract 3x from both sides. And then we divide everything by -4. Okay, and now if the slopes are the same, which they are, and the y-intercepts are different, which they are, so if these are the same and these are different, that means the lines are parallel. Okay. So both of these on 141, we're going to have to solve for y. So this first one, 3x minus 6y equals to 12. Subtract 3x from both sides, and I get -6y equals -3x plus 12. Divide everything by -6, and I get y equals to -3/-6, which is 1/2 x minus 2. So the slope of the first one is 1/2. The y-intercept is -2. The second one, we would subtract 6x from each part, so we have -3y is equal to -6x plus 3, and then divide everything by -3, and we'd get y equals to 2x minus 1. So here, the slope is 2, the y-intercept is -1. So you see that these two are not the same, so they can't be parallel. But they're flipped, but they're not opposite sign. So that means they're neither. So that just means that they intersect at some spot, but not at right angles. Okay, so here y equals 2, the slope is 0, and the y-intercept is 2. That would look like that. And then y equals 6, the slope is 0, and the y-intercept is 6. Look like that. So these are parallel. And that's the end. So are there any questions on any of this?